say Susan wants to go to ShopRite, to the mall, to go and to Palms Mall to go and shop for some items. So she has written all of them on. She has written a list of things she wants to buy. It could be the first. It could be the 10th item on her list that she buys first. Then she cancels it. Then she goes to maybe the 15th item on her list. Then she cancels it. So a list, that one is almost anyhow. You can navigate through a list anyhow. A tree, there's also a tree. There's also a tree algorithm. There's a way you navigate the tree, and you navigate the tree from the roots of the tree to the leaves of the tree. Then there are arrays. Arrays is like uh, array is like a a combination, a list of numbers, a list of numbers that, or a list of items that have the same um, a list of items that have the same properties. An array. When you say an array of soldiers, you cannot have array of soldiers and police together. So array will have the same kind of data set. It's the case, same type of data set. I'm going to explain some of that to you before I hand over to Emmanuel. Then you also have vector. Vector is like a two by two. It is like a two by two array. It's like a two-dimensional. Yes, it's like a two-dimensional array. So a vector or a matrix has a rows and columns. So yes. So a vector or a matrix is like a combination of a number. It's like a combination of a number of arrays together, but having the same two dimension, or having the same dimension. So those are different type of data structure. So if you have a project, depending on the sector that you belong to, whether you are in the bank and you will need to manipulate data in the bank, you need to understand what is the structure of the data that you need to manipulate. The structure of the data that you need to manipulate will determine the kind of function you can apply on it. In fact, it to some extent to even determine the kind of tool that you can apply on the data set. So it's very, very important. Most times when people struggle with things just because um, maybe they're applying the wrong tool. So maybe you are somebody that is manipulating a tree, for instance, someone that's manipulating a tree, and the person is using an algorithm that is meant for a stack to manipulate a tree. So he may achieve results, but that result is not going to be efficient. Or someone that is manipulating a vector and is using a tool that is meant for an array, the person may also achieve results, but it's not going to be an efficient result. So that is why we are going to spend time to look at the different type of data sets that you have in 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 R. Yeah. So one of the functions we'll be talking about today is the C function. So C function is the function that you use to create an array. So I talked about an array. So C function is a function that you use it to concatenate. So it's used to concatenate a number of items together. So let me just put it that way. So if you want to concatenate a number of items together, you can use C function to concatenate a number of items together. And that concatenate function also exists in R. So, no, also exists in Excel. Yes. So put that Excel where it's function that concatenate. So if I want to concatenate the Ola and Deji together, or if I want to concatenate Ade and Jumo together, so I can use a concatenate function to combine those two together into one. So maybe there's a first name and a last name, and I want to concatenate them together and create a new column that is called full name. So I can use C function to do that concatenation. And that is going to be relevant when you are doing feature engineering, when you want to create a new feature out of some existing features that exist. So there is a C function. You are going to try your hands on that. It's a very simple function. Then And then so that function can be passed into a variable. So you can pass that function into a variable. Yeah. So you can pass you can pass it into a variable. And yes. So what is done here, what is simply done here is you have a variable is created. That variable is called data1, and this set of numbers are concatenated together, and they are passed into a variable that is called data1. Then so we want to create a second variable. That variable is data2. So we are concatenating data1, which is already like a concatenation or an array of numbers. It's an array of numbers. Then we are now concatenating it with another set of numbers. So you have a variable which is like an array, and you are joining it with another set of other arrays in order to form a longer array. Of course, you can find that handy when you are joining like multiple data sets together from different sources. You can join days of the week together. Uh, you can join um, you can join days of the week together. You can join string together with you can join strings together. One unique thing about the C function is that the type of data sets that you join together, they must be of the same data type. They must be of the same data type. So if you are joining numbers together, it must be numbers that you are joining together. If you are joining strings together, it must be strings that you are joining together. If you join numbers and strings together, it is going to be taking the string. It's going to be taking the numbers as string. It's going to be taking them as string. So um, at this point, I'm going to hand over to Emmanuel. So because these things are better demonstrated, they are better demonstrated than just to talk about them. So Emmanuel, if you are ready, maybe you can launch into the lab environment and then take us through the practical session for all of this.
Okay, hello everyone.
Hi.
I might not necessarily use the virtual lab environment. I'll just use the house. You have house to be on my personal computer here, so it's not necessary for what we want to do today. So, though I can use the virtual lab, doesn't matter. Any which one, we still achieve the objective today. Or maybe I just launch the lab. Let me just launch the virtual machine. I want to share my screen now. I believe you should be seeing my screen now. So I'll be launching my virtual lab environment. Okay. Let me enlarge this. So we have talked about so many things in the previous class. I think we've covered a lot in the previous class. So we still have a lot more to cover actually. So let's see how far we can go. So I'll just log into HD user using HD user as password. So then let me enlarge this. Okay, I'll launch my house studio. All right. I think this is better. Okay, this is what we did in the last class. Okay, so I would do this so far in the last class. I want to create another, open another script so that I can have a finished page. Okay, so are we together?
Yeah.
Okay, so I want to quickly explore the function called scan. So I would like us to quickly explore that in 5 minutes. What does scan does? So scan helps you to, it gives you flexibility to call in your data, and so it gives you flexibility to call in your data, and maybe you want to type in the data manually instead of using the concatenating function C. So it gives you that flexibility. So first of all, let's see. If I want to input, give an input in this format, so this is the function scan. So let's say I want to give it to a variable. I want to go to vector, then I will say is equals to scan, then open and close brackets, then Ctrl Enter. So if I press Ctrl Enter, it's going to take me to the console where I can type in whatever I want to type in. Now if I do this, so I have this down here. So I'm being prompted to enter my data. So let me say I want to type. So I'll come to the console here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and maybe 10. Then enter. Then to finish to show that you have finished entering your data, just click enter again and set it's read 10 items. So if I want to see what's inside my VEC, then I can do this. So I have 1 to 10 in my VEC variable. So I might want to check the class of my VEC variable. So let me say, so it's numeric, okay, numeric. Now another thing is you want to have you might want to input your data with, separated by comma instead of naturally it's space, but you want to specify by comma. Then let me use another VEC1. Then I'm going to do something like this, scan. Then I will specify this, that I want to separate my inputs by comma. Then I should enter. I have this prompt in my console, and I can do the same thing I did the other time. Comma 2, comma 3, comma 4, comma 5, comma 6, comma 7, comma 8, comma 9, comma 10. Enter, enter. So this is done. We had 10 items. I can also call it VEC1. So I have this. But in this case, if you put a separator as comma when you are inserting your input, if you give it a separator as comma and you are imputing without comma, so it's going to assume that everything you just typed is a single character. So you have to take note of that. Then, if what you want to type in is a string, so you are going to do something like this. Is equals to scan. Then you are going to specify what. Then you put in quotes character. So this is going to know that, okay, what you want to put into this is a character. Let me call this vector 2. So this is going to tell you that what you want to type in is a character. So enter, and if I should type 1, 2, 3, 4, 5, 6. Okay, sorry, I'm not typing in console. 1, 2, 3, 4, 5. Then enter, then enter again. You got 5 items. So if I should call it, you can see it's now enclosed in with quotation mark. It shows that it's a string. Okay, that's by the way. Another thing is I might have a data set I want to call in my if I want to call in a file in my local storage, so data1 is equals to scan, then I would put inside the scan that file is equals to file.choose. Then if I should run this, it's going to prompt me to like my file explorer where I can get the data. So this is going to do that for me. So let me open this now. So you see, I run this, then it showed this guy. Then I can go to wherever location where my data is stored, then pick it from there. So let's say I want to pick from the data set folder. Okay, I think I don't. Let me see. I want to pick this employee's data. This employee data. I don't know what kind of data it is, anyways. Let me see this. Okay, let me pick this employees.csv. Then, okay, it's saying there's error, blah blah blah. So something like I have to let me put a separator so and give it. Let me put another parameter. So let me say what is equals to character. This should pick it better. Then, so okay, this might not be the best way to go about this. So what is equals to character, then separated by comma. Then I do this again. Then I come here and I pick my file. So we don't have this error. So it's 35 items. So we can see what is inside. Data 1. Then okay, we have this. Okay. So are we together? Are we making sense?
Emmanuel, so now, from what you just coded up there now, so it's as if you've converted every data type of each column in the data set into a character. Yeah, so how about, I feel it should still work if you don't put your character argument in that line of code and just put only your separator argument.
Okay. Yeah. So let's see that. Yeah.
So basically, it's the separator it uses in identifying the file. That's why it's in shell.
Yeah. So let's see that. So let me pick it, then pick it again.
Yeah.
Then you can see it brought up an error.
Okay.
That's why I say this is not the best.
Okay, so that means the scan function is not ideally meant for reading CSV files. Yeah.
So that's why I say this is not the best way to do it anyway. So if you just do this, this is going to override the error. Oh, sorry, this is going to override the error, but it's going to save you the stress of trying to convert other columns to their normal data type.
Right. I was just saying that because I feel you are losing information that way by following this. So I believe probably there's another function for reading CSV or data files.
Yes, exactly. So since what I want to read is CSV file, and I don't want to use the characteristics of each column of a particular data. So this one is the limitation of this guy is that it's not going to read based on the characteristics of each column. So it's going to consider it as a single as everything as a single character. Is either it's a string or it's numeric. So that's the limitation of the scan function. So let's use the read.csv function. Now I can also use this. I can also specify file.choose. I can do this here too. Yeah. I don't need to put a separator if I'm using read.csv file, so it's a comma separated file, so I don't need to put a separator. So I can just run this, then go to this place and pick up my employees.csv file. Then I load it and I call it data2. So we have this. So I didn't lose the information. Now, but you notice that when I call this guy, it took the first row of my data as the header. My data does not have an header. My data does not have an header. So by default, header is true in the read.csv format, in this read.csv function. By default, the header is true. So if your data does not have header, so to overcome this challenge is to put another parameter, which is header equals false. Absolutely. Header equals false should help us overcome this challenge. Hello, Susan, are you still on this call? Is Susan still on the call?
Yes, I'm with you. I'm listening.
All right. So let's run this again. Okay. Let me pick my employees.csv data. Okay. So let me see what's inside. Now, my first row is no longer an header. It's now normal. Okay. So let's see. I want to see the class of my object, which is data2. So let's see. It's a data frame. So it's a data.frame anyways. A data frame. So if I want to get the column name of my data frame, what do I use? I use names into the data itself. So this is going to give me the column name of the data. So I have V1, V2, V3 onto that. So I might want to change the column names. All I need to do is to assign this guy to a vector having the names. So let me call this. Let me call the first column name. Let me call it name. So let me call the second column. Second column does not have anything, it's a null value. So let me call it null. So let me call the second column. I think it's, let me say this is first name. Let me say this is first name, I guess. And call this last name. Last name. Then call this I think this is instrument, or I'm saying sitar, trumpet, guitar, blah, blah, blah. Let me say instrument. Should I call it instrument or job title? So I usually like writing my column name. I don't like giving it space. So it's kind of a tradition, nomenclature for naming columns. Avoid to use spaces. So gender, then I have this one to be. I have two dates there. Maybe let's say this is date of birth. Let me call it DOB. And let me call this another, maybe it's date of employment, or yeah, maybe employment date. So I have this. So if I want to call my data2 again, so the names has changed accordingly. Now, okay, this is a good achievement. So we have renamed our column, we have everything sorted. I've already put us through how to index our data in a data frame, vector matrices, and all. So let's say I want, look at this second column. I don't need this second column because it doesn't give any information. Everything is null, so I don't know anything about the second column. It doesn't make any sense to me. And I want to remove this. We are delving into data analysis, dealing with missing data, but it doesn't matter. So let's see data. Let me say data2. I should be able to do this. Let me see. Okay, data 2. Data 2. Let me see. So data 2, let me call data 2 again. Something that didn't work out. Okay. I didn't get that. So I'll just do something like this. Let me bring in the data set again. So there's another way I can do this. So let me rename the column name. Okay, I have my data back. So there's the way I'm supposed to do this, sometimes. But you have millions of ways of getting things done anyway. So I know that my column here is the second index. The column I want to remove here is the second index. So I can do something like this. So I'll say data 2 is equals to data. I want all the rows. Then I don't want the second column, so I'll do -2. So I want all the rows, but I don't want the second column. So this is going to remove the second column for me. This is going to remove the second column for me. So this should. Okay, I didn't put 2 here. That 2, and okay. So if I should run this, then I should run this. The second column is no longer there. Second column is no longer there. So I'll be able to remove the column with the null value. I hope we are not getting confused. Are we still there? All right. So let me move to. Am I still on this agenda for today? But there's a lot to do. So sometimes you might have a tab separated value. You might have a txt file and all of that. So the best way, if not a CSV file, the best way to read another kind of file, which is not a CSV file, is using the read.table. So let's see how that goes. So let's go data 3 is equals to read.table. We have so many of them. The delimiter, we have table. Most common read.table, read.delimiter stands for like the tab separated value. Then CSV. These are the 3 common ones. So let's use delimiter. This to read tab separated value. So file.choose or file equals to file.choose. Then let's check this first. So let's find a tab separated file. This guy is a tab separated file. It's a TSV file. So tab separated value. So this is a TSV file. I think it's the only TSV file that we have here. Let's check this place. So that's the only TSV file we have here. So let's use this guy, then load it into the environment. Yeah. Things still loading. Data 3. The thing is still loading. It's not coming up here. I don't know why. Let's see. Our console is not picking up. Our console is not picking up. So let me do something. This is not working out. Our console does not want to come up. Hold on. I think there's something wrong with my VMware. So let me just go to my house studio. So I think I have to open it. Sorry about that. So that's about that read dots. We have read dots cable, we have read dots delimiter, that's delimiter, we have read dots CSV, but CSV file. So I've talked about how you can save your file. So you want to save a data after doing some manipulation. So you can do, maybe you want to save it as a CSV file, you can do write.csv. That's the essence of using House Studio. If you want to write a command or a function, you want to use a function, it's already giving you an hint. So you can, so if you might not even remember, maybe you just glance through and you see what you want to do. So that's about that. So write the CSV to save as CSV file, write the table, which is a more general kind of writing files, and can explore all of this. So how do we deal with missing values? How do we deal with missing values? So NA when you see in a data frame, when you see NA, it's not available. So you know that the value is not available, the value is missing. So that's how you know when you have missing values in your data set. So we are going to see how to deal with missing values proper to proceed. So let's say I've not written much here. Let's say I want to read the data into this place. And data is equals to read.csv, then CSV, and is equals to file.choose. So this thing comes up here. Then I want to read this guy. This guy is a kind of time series data. So data one. So this is the data I have here. The time series data, anyways. So this is what I have. And I want to see the head. So I'll say head of data one. I think I've talked about this before. This is going to give you the first six rows. And I want to see the last 6 rows by default. Scale of data one. So you have this. So maybe I've done some manipulations. Then at the end of the day, I want to save this data one. You know, first of all, the data one is originally the file you imported. So after doing some manipulation, your data one might have changed, and you might want to make use of it later as a CSV file. Then you do the write.csv. Okay, let me see. I want to let me do something. So let me say data, sample data. Out of this data, I have 1,000 rows here. Out of this data, if I want to pick a sample, I'll say sample, then 1,000. So I'll specify the data I want to pick sample from data one. Then if I want to maybe replace, you know, what you do is statistics. Then is say you maybe without replacement or replacements. Let's say there are 5 balls in the bag. So if I pick 3 balls and all of that, so it's like you dip your hands into the bag and pick one ball. when it is with replacement, then you return the ball, then you pick again. It's possible you pick the same ball. But when it's without replacement, and then you pick a ball, you don't replace the ball, then you go to pick another one. So in this case, we are not doing with replacement. So by default, replace is false. So I don't need that. Then I have to specify size. Okay, out of 1,000 data sets, maybe I just need 400. And I can just run this. So it's saying that cannot take a sample other than the population. It is sample other than. Okay, so let's replace. This is equals to false. Sorry. So sorry, true. I wanted to say true. I said false. True. So we have this. So let me say sample data. So this sample data, I want to let me check the class of my sample data. Let me check the class of my sample data. The weight is somehow. The data frame. Okay. The sample data that's let's check sample data that's sorry, head of sample data. I'm using Python for the sample data. Okay. So this guy, I might want to use this guy. This guy might not really make a lot of sense here, but the way he's speaking it, So I might want to. So the essence is that we have done the manipulation. I want to make use of this data. So you could just write .csv. Write .csv and what sample data. Then you specify the file name. File is equal to so this is not correct. So let me call it sample data. Sample data.csv. So if I should save this now. So the issue I have here is this. The issue I have here is this. My house studio, working directory of my house studio, I don't have permission. I don't have rights access to my current working directory of my house studio. So to overcome this challenge now, I have to reopen my house studio I'll run as administrator. So let me close my house studio again so that you can see what I'm talking about. So let me save this. So I'll open my house studio again. And I run as administrator. I've already saved the work I did. So that's by the way. So I think this is So I have this guy. I don't know what I say. So let me just go ahead and pick it. I don't know why my house studio is just having this trying to mess with me today. My console has started the same thing as what's in the It's the same thing you did with the VMware. It's doing it now. Maybe I shouldn't be using this function as the choose. So it's actually doing it right now. Let me go back to my VMware environment so that has been sorted out. Okay. My VMware has come back to life. Sorry. Has come back to life. So let's continue from here. So that's by the way. So I'm also need to save maybe the objects that I've been using in this class so far. So let me just see. The ls command is to see the object I've been using so far. So I have these objects. So probably I want to save them. You might specify the certain objects you want to save, or you can just save everything. So I can just use the save function. Then I can pass my ls command into a list. My ls command into a list. So then I'll say file is equals to see it's going to save my current working directory, so I can say my object dot out data. So use this extension used to save. So my object dot out data. So don't start again. Susan, are you still there, please? Hello, Susan.
Yeah, I'm still here. Do you mind restarting it or something? Or what do you think? Maybe if you restart it, it'll be fine. Okay. Okay.
If it does it again, I think it's probably what I'm doing is taking out time. So if you do that again, then I will restart it. So the next thing we move into manipulating and processing data in R. Manipulating and processing data in R. So first of all, I'll save this my objects.out data in my current working directory. So let me know my current working directory. Get working directory. Oh, I think I have to restart. It's slow responding. So home/hd user. So let's go to. I can just go manually to file here to go and find it. So let me go to the file here. I think I have to restart this. It's actually taking time. I don't want to open file. It's taking time. So you can see the object that I just saved now. My object.out data. Or maybe I have to switch system. Maybe this system that is doing that. So we've talked about subsetting data. Subsetting is just indexing and getting subset out of data, because you might not necessarily need all the data. It might just be some subset for you to. So I've talked about vectors, matrices, lists, and data frames. Susan, can you please help us with the difference between vectors, matrices, lists, and data frames? So continue. Hello, Susan, are you there? Yeah.
Difference between matrices, vectors, and what?
Matrices, vectors, lists, and data frame. Those four.
In R or just
Yeah, in R, you're talking about R, in R, yeah.
like I don't know. From what I know a matrix is a vector of what do you call it now? Two attributes, that is the rows and the columns, right?
Yeah.
Then that's matrix anyway. Between two attributes, row and columns, then what do you call this other one now? Did you say data frame?
And let's go to list.
List.
Yes.
I should go to list. I'm trying to add everything together from what we discussed last week. I know a list.
Okay.
How I put it now? A list in R allows you to gather a variety of objects under one name. For instance, we did something last week. There's no way, you know this R, there's no way I can be saying it without practicalizing it though.
Yes,
If I'm saying it, it's just English I'll be saying. I don't know if you get my point.
English I wanted to say now. What you particularize, be able to. Well, I think before I did the practical, I actually explained. So because these questions are like the question I got to use in the examination. You can say what's the difference between a vector and a matrices. What's the difference between what differentiates a matrices from a data frame? What differentiates a matrices from a list? You should be able to. So because you might not really see it in practical, they might not say, okay, this which one is matrix, which one is list. They'll just ask you what's the difference then.
And so if I'm going to differentiate from my own understanding, if I'll differentiate between a vector and a matrix, I would say a vector is a list of numbers, probably between rows and columns, and a matrix is an array of numbers. It could be two-dimensional array or three-dimensional array. Do you get? Then which other one now? Lists and vectors. A list allows you to gather a variety of objects under one name. Do you get? It could be numerical. It could be numerical, character, or logical. Then a vector will store elements of the same data types, right?
Yes.
And I think from what I know, a list is a multi-dimensional object, and a vector is a one-dimensional object, right?
Okay.
That's what I know.
Okay, good.
Yeah.
Sure. So you talked about matrices being it can be two-dimensional, it can be three-dimensional.
Yes.
So a matrix is only two-dimensional. It can't be three-dimensional. So what do I mean? It's only row and column. It's two-dimensional.
That's an array of numbers now. A matrix is an array of numbers.
Yes, it's a two-way thing. Rows and columns. That's what dimension. So it's two-dimension. So matrices and vectors, what they have in common is that they can only take one data type at a time. But the difference between a matrix and a vector is that a vector is one-dimensional, while a matrix is two-dimensional. Now, a data frame is also is like a spreadsheet kind of data, rows and columns, so it's two-dimensional. But one thing is that in a data frame, each columns must have the same field, each field must have the same record, the same number of records. So what I mean is that for column A and column B, column A has 40 records, and column B must have 40 records. So and each columns is unique to its data type. So for a particular column, a column cannot have more than one data type. So column A, if it's numbers, it will be purely number. Column B, if it's character, it will be purely character. Now, a list is like the father of them all. Be it vectors, be it matrices, be it data frames. they can be compiled into a list. So a list can take anything. So that's the difference. A list can take anything, just be putting it inside. So that's so that's the real difference. I hope I'm able to do justice to that.
Sorry?
I said I hope I've been able to do justice to that.
Yeah, I get you. That's fine.
So I'm going to share another screen because the way this system is doing me, I don't understand. I have to use another PC. So these guys get to go off now. Okay, I believe you guys can see my next one. I will just open. I can just open. So we already done indexing and the likes of them. So we know how to index any types of data frame. So I believe you can see my screen.
Yeah.
Okay. So you can also you talk about taking samples from data.
For those other one that didn't work on the all those ones they're trying to do on the other machine, are you gonna do it here?
What did I do from the other machine? Let me see.
Like you are trying to get the missing values and all missing missing files. You know, it didn't show them.
Okay. So
I'm just asking, I don't know.
If you get there before time runs out, then so let's take step by step. So now I'm in another new scoop. I don't know whether you are seeing a new scoop with that. Okay, you are seeing it. Let me code the data again. So let me see my one token directory. Get token directory. So I'm under documents. Documents. Now I want to change my token directory. Let me download. I don't even like this. Let me go. So the direction of changing working directory is I don't change working directory. I don't have permission in this place. It's all good. It's all good. I hope I have a good direction. Let me see. I hope I have a good direction. I know I'm having this communication. I don't want to start again. It's just giving me stress of running at administrator. Yeah. This is my house. I don't want to open my VMware instance. That's what I'm trying to. Okay. Get working directory. Let me see if I can do this now. And just come to my VMware. Many later. So let me see now. So let me try. Let me see the data I have in my. It is download. And I want to play with some data. I don't have anything. We are going to see you can perform arithmetic operations on data types. I think we've done that. So if you have a data frame, your data frame is like a spreadsheet kind of data. You can perform operations on each column. Say you can add 2 columns, you can divide 2 columns, you can do many things. So let me just use the function data in R. So there's function called data, whereby you have some inbuilt data set that is in the R environment already. So let's say air passengers. So these are the data sets you have in R already. So let's say I want to use the iris data set. I'll just go to iris here, and I'll call it. And if I want to use it, I can say iris. Then this is going to. So this is my iris data set. This is my iris data set. This is my, okay, let me see the head. I just want to see the first 6 data set. So it's telling me something. I think, okay, so I'm seeing head of iris. So this is the first 6 data of my data set. So I might want to do something like maybe I want to divide 2 columns together. So let me say X is, I can say X is there's one thing I didn't talk about. So if I want to subset this guy, this first column, you know, I can do this. Iris, then I need all the rows. Then, okay, let me just put the first 5 rows. I need the first 5 rows. Then I just need the first column. Then I'll just put a 1 here. Then just give me the first 5 rows for the first column, which is 5.1, 4.9 to this place. Now, if I want to subset, I can subset this way, and I can subset this way by using this ampersand, the ampersand operator. So you can see it has already highlighted the columns I have in this data set, sepal, length, width. So it's telling me that, okay, which one do I want to call in all of this? So probably I need the sepal length. So I will use iris ampersand sepal length. This is going to give me the column for sepal length. But we want this. So these are the entries in sepal length column. I hope you understand what I'm doing. So I might need to, okay, maybe I want to divide the sepal length by the sepal width. I can do something like iris ampersand sepal length divided by iris ampersand sepal width. Then this is going to assign the division of those 2 columns to X. So if I call X, this is the result. That is, by the way, there's what we call width and within functions. Width and within functions, how does that work? So I will explain as we move on. Now, if I'm using width function like this, now the advantage of it is this. I can write something like this. It's iris sepa dot length. Sorry, it is sepa dot length divided by sepa dot width. So who can actually tell me the advantage of this? Who can tell me the advantage of this? So the advantage of this is that instead of me to type iris ampersand sepa length over iris ampersand sepa width, so this has already told me that okay, this is the data, but you are calling these other ones that are the columns in this data. So just assign this to y. So instead of me to type iris ampersand sepa length divided by this, so the width function has already understood that okay, this is what I want to do. I hope I'm making a lot of sense.
What's the
Yeah.
don't use this example, just in plain sentence. What's the function of which function?
So which just helps you detach iris. So it helps you detach iris. What do I mean by that? It means that you don't need to, you want to call the column of a particular data, you don't need to reference all again. So instead of me trying to index again with iris, I'll just call the column separately, then do whatever operation I want to do with it here. So this first parameter is the data, then whatever I want now to do is the second parameter here. So it means that this result of y is going to be the same as this result of x. So I have this. Okay, what is this? I mean, okay, it's capital S, not small letter s, capital S and small s. Capital W, capital W, capital S. So if you want to check, if I want to check whether the result we got is actually the same thing as what we have in X, there's a function also to check that which is identical. So we want to check whether the result of X and the result of Y is the same. So this is going to return true if it's actually the same thing. So it returns true. Another way you can just like a very basic way you can say 2, 2. So 2, 2 is true because 2 is the same thing as 2. So do you understand what I'm saying? So now this, this operation we did here is like the ratio of sepa length and sepa width. Suppose now I want to add that particular result I just generated as a column in the iris data set. What I will just do is that I will say iris, then maybe ampersand ratio. So this one is not part of the data. So I'm now saying that this should be equal to this operation we did here. This operation we did here. I can just copy this and put it here. So this is going to add a new column ratio which is generated with this operation to the iris data. So if I should run this, then if I should say iris.head, head of iris data, head iris.
I'm not seeing anything.
Oh, let me enlarge my view. Sorry. Let me enlarge my view. Okay, if you are finding it difficult to see my screen, another way you can go about it is, I think you can use control plus or control minus. Any which way, there's a way it works. You can zoom in into my screen if you are using a system. I think that will work fine. That working? So did that work with you over there? Did that work with you? I can't hear you guys anymore. Okay. So I will do that by myself. So another thing is the within operator, the within function. So look at this thing I just did now, this operation I just did here. Another way I can use the within operator, within function to do this thing I just did here is use, instead of me saying iris approximation is this operation, well, it's not actually stressful to do. I can do this. Iris is now equal to, then I'll put the within function. Inside the within function, I would have my data, first of all, specify my data. Then, but what is the new amount to generate? Then what is the operation I want to perform on it? So this is the operation I want to perform on it. I will separate length and divided by separate width. But since I've done this operation before, I'll just use another column of the, let me zoom out, this thing is okay. So since I've already used this ratio before, so I think I will just use another, let me say ratio. So let me first see the head of iris. So I have separate and separate width. You can see that the ratio column that I generated earlier is there. So let me say I want to do petal length and petal width in this time now. So I'll just put P petal length, then come here to put petal width. So this is going to generate another column called ratio 2 and append it to the iris data set. So let's see the head iris. So yeah, you can see the second ratio has been generated as a ratio for petal length and petal width. So are we all clear to this stage?
Yes, we are.
Okay, all right. So let's also see using the, now there's a function called a table function. What the table function does is basically a summary of your data, but it doesn't really work well. It won't really work well with what we have in the iris data set. So let me give us an example of how the table is going to work out. So let me see whether I have kind of data that can work with that. Let me see data. I think they used to like, I'm kind of looking at the data that can work with the table function. BJ series, keeping weights, hair color. Okay, let me see hair color. So let me see hair color. Hair eye color. Yeah. Let me check the edge. Okay, hair eye color. This is a data frame. So this kind of a list. So let me see the class of AI class. It's not a data frame. Okay, it's a table. Yeah, it's a table. So this is an example of what a table can do for you. Like it's going to generate like a contiguous table. like a contingency table. If we did the statistics, you might be familiar with the word what they call contingency table. So if I have a table whereby okay, I can just let me come up with a table. So let me say my list is equals to let me call it list. So let me call it data frame is equals to data. So I'm going to the data frame. So this I want this to explain what the table function actually does. So let me say blue, red, blue, black, red, sorry, red. Then I think how many I have 6 rows there. So let me generate another column. So let me put here orange, apple, banana, and maybe apple again. Then let's have one more. Then maybe cashew. So let me see DF. What have I done wrong? That didn't work out fine. So let me just bind. Let me bind. C bind. If you don't want what C bind does, I will let me C bind before I convert it to a data frame. That should work better. You cannot. Am I missing it? Okay, there's still another bracket. There's supposed to be another bracket at the back. Yeah. So let me call it. So this is not the way I want it to be again. It's column bind I want to use. So I don't get that proper. So this is what I want. Yeah. So this is what I want. So I actually wanted this. So if do you understand what column bind is doing? If you don't understand what column bind is doing, I can explain. Hello, are we still here? Susan, are you still here?
Yeah, I'm still here. I'm still here.
Do you understand what I'm doing at all?
I'm following you. Don't follow.
Okay. So let's see what the table function is doing. So let me do table of DF. So it just do a cost tabulation, like it did a contingency table. First of all, it took the unique elements in the first column with the unique elements in the second column. Then it checks. Okay, when do we have blue and apple in this? First of all, the first is black. When we have black and apple in the same row? No, it doesn't happen. When you have black and banana in the same row, black and banana. Okay, I have it once. Let's record it here. So when we have black and cashew in the same row, there's no occasion. 0. Black and orange, 0. Okay, it comes to the next one. Blue. Blue and apple. Do you have blue and apple? Yes. Once. It occurs once. Do you have blue and banana before in the same row? No. Do you have blue and cashew? No. Do you have blue and orange? Yes. It occurs once. It occurs that. So it comes to red. Do you have red and apple? Yes. It occurs 2 times. So it gives the record 2 times. So that is how the table functions. The table function actually works. So do you understand how it works now? So that's why I don't want to use it with the iris data set, because it doesn't fit into what to what the function of the table does. So that's why I cannot use the iris data set to do that. Do you understand? Nobody's answering me again. I don't know what's happening.
We understand though.
Okay, so there's still a lot to cover. There's still a lot to cover. So now I want to move to merging now. Merging is just like joining SQL, combining and merging data sets in R. So combining and merging this data set. So just like the SQL join in any RDBMS database and any RDBMS. So I don't know if I have the kind of data set to perform the merging operation in this my current working directory, but I can just go and get. So let me check. Let me check my folder. I have some files I can play with. So let me check my downloads. Okay, I have these files. I can play with this file. It's under downloads. So let me see. I can get them. BTC. So it's Bitcoin data. So I can play with them with the merge function. So so let me get them into the data, into the R environment. So BTC is equal to read. They have all the file. So let me see if I can read them. I specify the path. What's my current working directory? Now, suppose you want to clear your console. It's too bulky. There are so many codes. I want to clear it. Maybe you don't need it. So the command to do that is Control L. Control L. So if I type Control L, everything is clear. So everything is clear. So I'll just continue. So I will specify the path. Then first get my working directory. So let me get my working directory. Okay, so I'll specify the path. Users administrator. I believe I have permission to download. I think it's under downloads. Then the file name is btc underscore usd.csv. So I've got the file into the R environment. So let me call the second file, which is Ethereum data. So I call that ETH. Then this one will be ETH. Then I load it. I call the next one, which is XRP. So I'll just edit this to be XRP. Then edit this to be XRP. Then I load it. So I have the 3 data sets in my environment. So if I want to see the edge of each of them, then you can do edge of BTC. So what do I have here? I have currency, I have date, I have closing price. So I would like to rename the column of this data set. So I don't like the way the naming is. So I'll just rename the column names. So BTC is equals to the first one is currency. I think I still like the way it is. Currency. Then let me call this date. And this is closing price. Closing price. And this is open price. Or let me say opening price. Then this is what follows is the high price. High price. And what next is price. So let me over there to this quote. So I think that is that. Oh, supposed to be names, not names. Sorry. So this is that. I've named the column for BTC data. So the same pattern for everything. They are the same kind of pattern. So let me just copy this. I'll change this to. So I'll change this to ETH. Yeah. And copy this again. And change this to XRP. So there are different data. But their naming pattern is the same. So I have this. So let me see the head now. Head of BTC. You can see you have currency, you have the date, you have the closing price, opening price, high price, and low price. So head of ETH. So for Ethereum, it started 2013 year and 1st of October. So that's for BTC rather for Bitcoin. For Ethereum, 2015, 9th of August. Then for let's say XRP, you have this. So let's say we want to merge this data. So I'll give us an illustration of how this actually works, because if you don't get the illustration, you might not really be able to catch up with me as I'm writing this thing. But if I give the illustration in writing, I think we better understand. So let me direct this question. Let me ask him, is Temitope with us?
I'm here.
Hello, Susan, are you with us? Susan?
I'm still here. I'm here.
Okay, so I will have to explain the concept of merging. It's in SQL we call it join and all that. So it's still the same thing. So I will have to explain the concept. So how many of us understand the concept of set theory here? We have the basic understanding of set theory, the union, the intersection, and the likes. Because this part is very important, very, very important. Maybe I should direct my question very well. So Susan, do you have the concept of basic set theory and that, so that I will know how I want to explain this? How about Temitope?
Yes, like SQL. Yes.
Suzanne is yet to respond. I don't need to call Victor. Victor, Victor should understand this concept. You understand this concept, so I'd like to call Victor.
I do, Emmanuel.
All right, so I would share another screen because I don't want to use the screen of this one. So I want to share this screen. So I want to use the whiteboard marker. So do I need to share this screen? Why? Let me check. Maybe I don't need to share this. So I want to use the whiteboard marker. But if I don't share my screen, I won't be able to see. So let me just share my screen. So I want to use the whiteboard marker. So can you see this screen? Can you see this screen? The whiteboard marker. I said the whiteboard marker. The whiteboard. Can you see the whiteboard? No. This whiteboard. I'm not using this. Can you guys see this part of my screen?
Yes, I can.
Okay, so if we have two tables, the essence of drawing is tables actually. So if we have two tables, I think I should finish that. So we have four kind of joins. We have the inner join, we have the left join, we have the right join, then we have the full join. Though in some cases they can say they will say full outer join, they will say left outer join, they will say right outer join. Without the outer, you are still doing join, so it's not necessary. In some RDBMS you might need to specify outer, but it's not necessary. It's not really necessary. I don't know why this is taking time to load. God. Good, why? Hold on. I don't know why it's taking time to do that. Let me try it on this second. I'm not using the Teams app. I don't really like to use the Teams app. Let me join using the I'm joining using the Teams call. I think this should work better. Maybe. Okay, I think it's finished. It's finished loading here. So let me just share my screen. I really don't know why it's taking a lot of time to. Now, so I didn't finish loading before. So so let me use the Teams app. Let me use the Teams app. Maybe the one desktop. So can you guys hear me? Can you guys hear me? Please, can you guys hear me?
Yes, I can.
Yes, we can, Manuel. We can hear you.
Yes, I can hear you.
Okay, first of all, we have the inner join. So let me first explain the concept of the inner join. The inner join. Don't mind this guy. So you have a table. You have a table 1 and a table 2. So let's say this is table 1. I think I should. Let me go to my Excel. I'll come back to this place. Okay, let me first. Okay, table 1, table A. Because if you really get this concept now, so to implement it on R, you understand what you're actually doing. This table A, this table B. Because doing it on R directly, you might not really see the picture. So table B. Now, this table A is this circle. So like set A. This table B is this circle. Now, if you are doing inner join, on these two tables, this is essentially what is going to happen. Now, before you can join two tables together, if you are doing inner join, then there's something, any kind of join, any kind of merging, there's something that should be common to both tables. Now, so this is literally what A, when you are doing inner join between A and B, this is literally what is going to happen. It's going to take set A and take set B. This is A, this is B. Then it's going to join them based on what is common to both of them. That's exactly what's going to happen. It's going to join A and B based on the similarities, irrespective of what is inside A or what is inside B. So any row in A or in B that are not common to each other, it will be excluded from the data. So maybe out of no, I'll explain this when we go to the spreadsheet. So this is basically what is going to happen. So let me clear this. I believe you have understand this concept of inner join. So it's basically what is common to both A and B, using a column that is particularly common to both sides. So let's say this is the employees table. Let's say this is the employees table, and this is the department table. So this is department table. Literally, we should know that, or the employees table should have the employee ID, which is unique for each employee. Now, there is a way that the employee ID is called the primary key in case of employee in the employee table. Now, the employee table can now have a foreign key called, don't mind all the technical things I'm talking about. The foreign key can be department ID. So for each employee, now three employees can be in the same department, right? Yes, 3 employees can be in the same department. So, but employee ID is going to be unique for the employees table, but the department ID in the employees table cannot be unique because we can have 3 employees in the same department. Okay, that's one. So it means we have department ID in the employees table. Now, department table is going to have department ID standard. But department ID in the department table is going to be unique because in the department table you believe that okay you are recording the information of each department. So and each department is unique to itself. So it means that the department ID in the department table is going to be a primary key which is unique. So if you are joining the employee table and the department table in this case, so it means that you'll be joining based on the department ID because that is what is common to both employee and the department table. So if you come to the employees table here, wherever it finds a department that is in the employees table and is in this guide, it's going to join those rows based on that. So if there's any employee table that is in the department, if there is any department ID that is in the department table, you know, department table is going to have all the department ID. But the employee table might not necessarily have all the department ID because maybe there might be a new department and there's no employee in that department yet. So, but that department is going to be in the department table, but that department might not be in the employee table because there's no employee yet. So if you are doing an inner join, that department that is not yet on the employee table won't be recorded in the inner join because there is nothing in common there. So that's one case. So I will erase this thing I've done. I will erase this. Then okay, I will erase this. Now, so let's talk about the right join or left join first. The left join. Now, if you are doing a left join on table A and table B, now table A in this case is the guy in the left, while table B in this case is the guy in the right. So if you are doing a left join, it means that you are selecting everything in A irrespective of what is common to B. So this is actually the result of a left join. So let me show you. So this is A, this is B. You are selecting everything in A on, but it's going to be based on what is common to B, but you are selecting everything in A. So whether there's something in A that is not common to B is none of A's concern. It's going to return that row, that particular row in A. But since it is not common in B, you know it's a data frame. All the columns must have the same number of records. So since a particular row in A is not common to B now, that does not mean that it's not going to return A. So for that part of A, B that is joining with A is going to fill in with null values. So that's the case for left join. Now for right join, this is left join. So for right join, I will erase this part. For right join, it's going to select everything in B irrespective of what is in A, but it's going to be based on what is common to both of them. But irrespective of what is in A, it's going to select everything in B. So the part of B for right join now, let me erase this. So, okay. So right join. So this is right. So this is A, this is B. Now for right join now, in the case of right join, it is table B that is in the right, table A is in the left. So the department table is in the right. It's going to select everything in the department irrespective of what is in A, but it's going to be based on what is common. So it is going to select this guy. Now remember I said maybe there's a department in the department table that there is no employee there. So for that department, let's say it's department ID 10. So for department ID 10, let's say it's the health department. So for health department table, there will be no corresponding record for it in the column in the in employees table. So for that part in the employees table where there is no department of health, that place is going to be filled with null values, but it's going to return each and every row in the department table and join it corresponding to what is the employee table. So the part of employees table that is not common to B is going to be the one that will have the null value. Now, if you are doing a full join now, so I'll just erase this. If you are doing a full join, you are saying that don't mind the way this thing is writing. I'm using the mouse, so it has been better with the light pen or something. So it's a full join. You are saying that select everything in A and everything in B in combine. So whether there is something that is in A that is not in B is none of my concern. Whether there is something in B that is not in A is none of my concern. So in this case, where there is something in A that is not in B, that place will be filled with no values for the part that B wants to join with A. And if there's something in B that is not in A, in that regard, that place will be filled with no value. But it's going to select everything in both tables and combine them together. So let's go to the Excel and see how this actually works out before we continue to add. Do you have any questions as regards this before we move to Excel? Please, I need your response, please. Does that make sense to us?
Well, yes, to me, the summary is just that. Okay.
So
Can you
in
hear me?
Excel, we are going to, yes, I can hear you.
What you're trying to say is that the inner join is more or less like A intersection B.
Yes, exactly.
Then what do you call the other one? The full outer is A union B.
Exactly.
Then this one is A complement union B, then A union B complement. Am I right?
But if you don't do if you don't do a basic explanation of this practically, you might miss the concept. So that's why it's not actually in that sense, but it's that concept. So we have to see what that thing is actually doing in that regard. So let me open an Excel, a free Excel. Yeah, I'm using the PPS. Don't mind this guy. So let me open a spreadsheet, a fresh spreadsheet. Okay. You wanna answer me now? So let me call this first table employees table. So let me say this is the ID, employee ID. Just this to illustrate, because you can get it here. If you are going to get it, you are going to do it. Employee ID. Then the next column is maybe the first name, and maybe this is the last name. I don't really need much info to explain this. Then this one is the department ID. Okay, good. So let me say employee ID. Let's say from 1000. Then this is maybe 1001. Remember, it's going to be unique for each employee. Then 1002 in that regard. So let me try and drag this to this. So let me say I have 1009. Sorry. Okay, so let me say the first name I have Adelaja, Adeniji, Olufemi. I have should declare. It's like a dummy kind of to explain what I'm talking about. Ogunlaja, Opeyemi, Adeniran. Ogunleye. I'm writing in small letter. Anyways. I want to type something. I know somebody is going to crucify me for this. So, last name. So let me see. Sunday. Solomon. Joshua. Idris. Oh, Temitope is this class again. Victor.
I'm here. Oh, I'm in class.
So let me say department ID. So let's say this person is in department ID 1. This one is in 2. This one is in 1, 2, 3, 1, 2, 3, 4, 4. So I want to create another table. Let me call it department. So let me call this department ID. Department ID. I don't want to use this. Let me use DEPT. So I just want to use, it's not necessary they have the same column name, but the concept is there. I can decide to write department ID here as DEPT underscore ID and come to the department table and write department info underscore ID. But you know that in this concept they are related. They are related. It is unique for each department. So let's say we have 5 departments. Let's say I have 5 departments. I want to create another column here. I want to create another 1010. This person is DG Blessing. This one is department 5. Okay. Let's say there's another department 6. Okay, good. So let me say department name. Yeah. Let me say this is marketing. This is sales, admin, operations. Training department, and this is stakeholder. So you have this information. Now, suppose I want to do inner join now. I want to do an inner join. So I want to do employees. I want to do employees. Inner join department. So what do you think is going to do based on what I've explained the other time? So if you are doing this inner join this, what do you think is going to happen? How many rows, how many records do you think you are expecting? Or first of all, let me ask, which column are you using? Are you using for your join? Which column will you be using for your join? So let me first ask that. Hello, are we still here?
Yeah, we are here.
Let me use as stakeholder.
You're going to use the department ID now, since that's what is common to both of them.
Yes. So now, if you are using department ID to join both of them, so what do you expect employees inner join department to return, what number of rows do you expect? How do you think he's going to do the joining? Okay, without wasting much of our time, I will explain. Now, this is how the join is going to work, the inner join. Since you are joining based on department ID, so for this first row is going to match up with this guy. This one is going to match up with this guy because department ID 1, department ID 1. So this is going to be one row. So you are going to have this. As a single row. So let me copy this and put it here. This is the first row. Now it's going to come to this guy again. This guy matches with this guy. 2, 2. It's going to return this as the second row. This guy, come and it matches to this guy, to the marketing. So it's going to copy this guy. It's going to take this guy. Let me paste it here. Then match it with marketing. This second guy, this third guy is also going to match it with marketing. This will be matched with marketing. So this place will be marketing too. Now this, where is the guy? Oh, I think I copied the wrong thing. I've done this before. So this one, I'll pick this guy. Sorry. So this guy is in sales. So it's going to pick this guy and match it with sales. So I don't need to be wasting much of time. So it's going to take this fourth guy and match it with sales. Take this and match it with admin. Take this, match it with department. Take this, match it with sales. Take this, match it with admin. Take this, match it with operations. Take this, match it with operations. Take this, match it with stakeholder. This guy does not match with anything, so it's going to exclude this guy. This guy is not going to be inside the output. This guy is not going to be inside the output because it does not match anything here. That is what Ignite Join is going to do for us. So let me just print the result. The result is going to look like something like this. Now join. So this is for sales. I'll just copy sales. Put it here. And this is for admin. Yes, for admin. This guy is also for admin. Then this guy is for marketing. This guy is for sales. This guy is for operations. And this guy is for stakeholder. So that's how it's going to do the match. Oh. This is going to do matching. So how many rows? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is that. So are we following? Are we getting it to this point? So do you get the concept of inner join? I'm not hearing anything.
Yes, Emmanuel,
I
yes.
got it. Yes, I did.
Okay. So let's go to left join now. Left join. So this is what left join is going to do. Left join is going to pick everything here, match it with this guy, depending on where they have something in common. So I want to add another column here. Let's say 1001. Another row entered. Let's say this person is an employee. So let's say this guy is an intern. Olani. So it does not belong to any department. It does not belong to any department. This place is null. Does not have department ID. So department ID is a foreign key, so it can be null. So for this guy here, it does not belong to anything here. In this case, it is not going to be among the inner join here. So that's by the way. So left join now. I want to give this a space. I want to put a space under it. Format insert self video. It's fine. So this is what left join is going to do. Left join is going to select everything here, then match it with this guy, depending on where they match. But it's going to select everything. So I'm just basically going to select everything here. Select everything here and paste it here. Copy and paste. There's no kind. Copy and paste. Left join. Copy everything in the left. Paste it here. Okay. Now let's look. Where does this first guy match this guy? Come and paste it here. So it's going to matches with this guy here. Paste. It matches with this guy here. Paste. It matches with this. Okay. Where does this guy here match with the guy here? It matches here. It matches here. It matches here. Okay. Where does this guy matches? Matches here. It matches here. Where does this guy match? Matches here. It matches here. Where does this guy match? It matches here. This guy does not match with anything. This guy does not match with anything. You can see that. So this guy here, for the place of department, this guy is going to be empty. So that's the part I said. In case there's something at the left that does not match with the guy at the right, it will be filled with null values. So this place is going to be filled with null. So you see something like NA. Then this one is going to be like NA. This one is also like an NA because there's nothing there. So this is left join. Now let's look at the what we call it, the right join. Employees right join departments now. Now in your mind, you might think I'll just come and copy this guy here and paste it here. Yes, that's the concept. But then something's going to happen. You can't just come here. It's that concept. If I come here and paste this guy here now, yes. But there's something that's going to happen. Something has to match with this guy. So select everything here, check where it matches with this guy. But everything here is going to be returned. Fine. So where does this guy match with this? We have this. It matches in 3 places. So this marketing guy is going to come up 3 times like this. Where does sales matches here? It matches here, so 3 times. So it means that this guy also is going to come up 3 times again. So I'm going to place it here. where does this guy matches with something that is here? So it matches 1, 2 times. I'll copy this, I'll paste it here 2 times. Operations also matches 2 times. So I'll copy this 2 times, paste it here. Stakeholder, it matches only once. I have it here. Health, it does not match at all, but I will still have it here. That's the concept. Health does not match with anything here, but it's going to be returned eventually here, because that's the concept. Right, I'm right joining on department. Department is the guy at the right. Everything must be selected. Whether it matches or not, everything must be selected. So this guy will now be matched based on what is at the right. So this guy is going to be here because it matches with this guy. Then, so let me first just select. Okay. Then this guy is going to match with this guy here. This guy is marketing. So to come and match with marketing, where's marketing? Marketing is here. This guy, it matches here. This guy that is in sales, where is sales again? So it comes here and matches sales here. This guy that is in what is it called? Admin, it matches with admin here. Comes here and match with admin here again. So this guy that is in marketing again comes and match with marketing here. This guy that is in sales comes to match with sales here. This guy that is in admin comes to match with admin. Have I pasted for admin 3 times? Solomon is in admin. Okay, I only did for admin is 3 times. Is it? No, it's 2 times. So where is Ogunraja Solomon coming in? Admin. Okay, I pasted it 2 times. Sorry, it's not supposed to occur 2 times. So this replace this. Then this person is in operations. It comes to operations there. This other person is in operations. It comes to operations here. Then this guy is in stakeholder. So where's stakeholder? It comes here. Now this guy does not match with anything here, so he's not going to be called upon. So, but this place that does not have a match, this guy that does not have a match in the employees table for the employees table is going to be filled with no values, not available. No values, not available. No value, not available. So this place, yeah, not available. So this place is available because it does not have anything. It does not have anything. So I guess you understand the concept now.
Yes, thank you.
Okay, so let's go to our environment. Fantastic. I will share my screen again. I think I will do my environment. Maybe I'm moving from one screen to another. Sorry, I have to just. Okay, so let me go to my house studio. So I have these guys. Here. Beautiful. Now, there is something that is common to these 3 guys. Who can tell me what is common to the 3 guys? If I want to join any of these 2 guys together, who can tell me what I can use to join them together? So I have BTC, I have ETH, I have XRP. They are all time series data. So you can see the first column is a unary column. It's a unary column. So it has only one item in it. You have the date, you have the closing price, and every other column from closing price downward they are just numbers. They're just numbers. So who can tell me how I can join these two tables together? Maybe the BTC, the ETH, and the likes. So who can tell us what is the column that can be used to join them together? Should I call names? Should I call? Okay, let me start from the person in my first list. There's always Susan. There's always Susan in my first list. So Susan, how do we? What column do we use to join our data together? So suppose I want to join Bitcoin, BTC, and Ethereum table together. So which column do I use to join them? Okay, the second person in my list, I don't know whether Sudan is still with us. Temilola, which column do you use to join this table together? Is Temilola to not with us? What about Temitope? Temitope and Victor. Okay, Temitope is talking. I didn't hear that. Temitope, you said something I didn't hear. Victor, what did you say?
I don't say anything. So I wanted to ask, is it just for the column names? It's just these ones we are saying: currency, date, closing price, opening price, high price, low price, right?
So yeah, that's just 5 columns there. I'll be 6 columns rather.
Okay, what we use to join from these columns will be the date.
Yeah, exactly. So we cannot use currency to join them because they have nothing in common. They are unary variables, so they are different from each other. Date, yes, date. They are daily data. They are daily time of data. So it's being collected daily. And closing price, you can't join by price. You can't join by price because price is not an ID. It's not a kind of ID that you can use to join. So it varies for each kind of data. So you cannot join with price. So every other thing there is price. So you cannot join with price. So the only thing you can consider is currency and date. But you cannot join with currency. You can only join with date. So it's this that is the column that you can use to join these two together. So let's say if you should see properly that BTC started from 2013 and Ethereum started 2015 while XRP started 2019. So if you are doing an inner join between BTC and ETH, it means that from 2013-14 for BTC it's not going to be in the join because Ethereum does not have data for 2013 to 14. So it is going to pick from where Ethereum started and join it with Bitcoin, which is BTC. So the joining is going to be based on the column date of Ethereum that matches with start of BTC. So it means that the join won't cover from 2013 because because BTC has 2013, but Ethereum does not have that. So let's try and join BTC and Ethereum together. So let me say BTC. Let me call it BTC ETH. So the function we use to do that is the merge function. And the interesting part of it is this. So if I do this, it's going to tell me something like this. Write my X and Y. So I don't really want it to return all the columns, because it might be too bulky. You might not really see the picture very well. So I'll just pick the first 3 columns and join the next 3 columns. So let me say BTC. I want to pick BTC for the first 3 columns, then join with ETH in the first 3 columns. Now, if you don't specify the column you are using to join, even if you don't specify whether it is maybe by join by X, whether it's by Y or all of that, it's going to pick it as probably you are doing an inner join. So if I should just do this, if I just leave this and just write merge BTC ETH, literally what it's supposed to do for me is an inner join. But then we're gonna specify whether it is blah blah blah, whether it's by. So I'll ask this kind of intelligence. If I should write like this, I should be able to pick the column that is common to both of them and just do the inner join for me. So let's see how that works out. So this thing has run. So let's see BTC underscore ETH. Let me see the head. Maybe the first 10 rows. Wow. It didn't work out the way I wanted. So
I think it's because of the data. I think the dates years are not similar. Like there's 2019, there's 2015.
I don't think that's the case. So there's something I will probably going to do. If I don't specify the by, then maybe I will have to convert to a data frame before I do the merge. But it's already a data frame anyways. So let me see. Let me now specify the by condition. So let me say by date. So let's see how this works. So let me hide this thing. I think it's blocking something here. So I've specified by date. So let me see the head. So that works out. So I think I was not smart enough to do that for me. So one thing I was smart enough to do is that, you know that currency, the naming nomenclature of the column is similar. Naming nomenclature of the column is similar, but I was smart enough to tell me that this one is for the guy at the left and a particular one is at the guy at the right. So column.x is the currency for Bitcoin. Currency.x. So currency.y is the one for the Ethereum. While currency and closing price.x is the closing price for Bitcoin. While closing price.y is the closing price for what do you call it? Ethereum. So you can see that it's only fixed for 2015 because you are doing an inner join. So Ethereum does not have data to match with Bitcoin at that particular year because you don't see have the data. So it only picks for the part whereby it has the year. So if you check our Ethereum head, it started from 9th of August 2015. So if you see the joint we did, the inner joint, 9th of August 2015. So that's the place at which it matches with the Bitcoin. So it catches that. So if you want to see the tail, the tail is actually the same for the tail is actually the same because the data I gathered was their endpoints. Their endpoint is the same. That they close the same gate, so it should be the endpoint should be the same. So tail for BTC underscore head. Sorry, I'm saying underscore head instead of ETH. So you can see 23rd of 7, 2020, and that is where the tail of Bitcoin. Where's the tail of Bitcoin? Okay, I didn't find the tail. So that's where the tail of Bitcoin and lies ended too. So that's by the way. So now, if I should repeat this line of code now, if I should copy this code here, this is inner join. So I want to say I want to call this one right join. Right join. So I'll put RJ to specify that. Okay, I want to do left join, LJ. So left join in this case is you are picking everything in Bitcoin, then match it with Ethereum. But Ethereum does not have the match of Bitcoin. So for that part whereby Ethereum does not match with Bitcoin, will be replaced with null values. So for that part of 2013, 2014 that Ethereum does not have the data, it's going to be filled with null values. So to tell the environment that what you want to do is a left join, you're going to do by.x, which is the X part, which is the Bitcoin, is the guy at the left. So I'm joining based on Bitcoin now. So we are going to see that it's going to start from 2013, but the part of Ethereum that does not have the data is going to be the null values. So let's see this. Oh. What am I seeing? This. What I have to do? Okay. Let me see whether this works. So I have to specify all those x equals true. I think I have to do this. Sometimes how can be so frustrating. Wow. Did I miss out something? It said specify different number of products. Okay, what if I use all? What if I use all? There's something that's still missing here. What if I should remove this and put all.x? I don't know why it is doing this. Okay. Let me see whether that works. But it's supposed to pick that. I should be able to specify what I'm doing. Let me just choose the head. I think choose the head instead of having to specify all this. But there's something on BTC underscore ETH underscore left join and MC the head of the I feel like there's something wrong with this result. This is not what I want. This is not what I want. This is not what I want. By.x. I don't know why it is rejecting this. I don't know why it is rejecting this. So are we still together in this class? Hello, Victor.
Yes.
So I'm trying to do a left join to the data set. Is giving me some stuff I'm not expecting. So just give me a minute.
Let's see. Yeah, you're correct now.
Yeah, because I don't really know what is happening exactly. So sometimes this thing can be so frustrating. Hold on. We still have stuff to do. Okay, I think let me just see this. There's a function in R to maybe you are confused of you don't really understand what is happening about a particular function. I think you can just check some example. Okay. There's another one. This doesn't work out. Demo. So let me see image. I'm trying to look at the image option. Wow. Okay, what about this? Image. So it's getting this prompt. So you can to find how this actually works. So merge X and Y are the two things you want to join together. Okay, it's got to intersect names, blah blah blah. By.x is equal to by. So when I run this, so by the execution of the use for magic. I'm seeing something here. All is equal to. So let me see something. It's going to be this. All is equal to. Is equal to 3. That still doesn't work out. So let me try one more. Dataset names BTC, but this is taking too long. I don't think all this is necessary. But BTC, comma news ETH. Unexpected season. It was supposed to be a comma here. Let me see what this is. It's still not what I'm looking for. It's not picking. It's not picking what I want. It's not picking what I want. But it's posting. Okay, let me try this one. All right, this is it. Sorry about that. It's actually sometimes you just have to debug and debug. I hope this makes sense to us, please. I hope this makes sense to us, please. Before we move on. So merge this guy and this guy. All dot x equals to true is telling that is a left join. Then by what? By date. I think when it is necessary to put by dot x and by dot y is that when the two, maybe the column name of what you are using to join those two tables together is different. So let's say department ID in the employee column is spelled as DEPT_ID, and maybe in the department table is spelled departmentinfo_ID. That's when you need to specify by.x. So since it's the same, a simple by of the column name is going to do the job. So you can see for 2013, for that part of Ethereum, it is not valid because it does not match. It does not have this data of 2013. It does not match with it. That's why you have no value there. So if you check the tail, you see that it matches. It matches with the Ethereum at that point. So tail. So you have the data here. You have it here. So if you want to do a right join, in this case, a right join is going to be this guy is going to change to all.y, and everything remains equal. All things being equal, everything remains the same. RJ, so let me call it RJ. This is going to be a right join between the Bitcoin data and the Ethereum data. Now it's going to select everything in the Ethereum data set, irrespective of what you have in the BTC data set. So the way it's going to be to join, select everything in BTC, match it to BTC. So it's going to, you are going to see that The result of this right join is going to be the same thing as the inner join we did, because the date in Ethereum is also available in BTC. So there's no way Ethereum is not going to match with BTC. So there's no place in BTC that does not match with Ethereum. So it's going to be like an inner join. So let's see the result of BTC underscore ETH underscore RJ. So this I've not created the object. Okay, I've not created it yet. So let me run this. So this is our right join. Let's see the head. Okay, this is the head. You can see it started from 9th of August, blah blah blah. So you can confirm that the inner join of these two tables and the right join is actually the same thing by using identical BTC ETH, which is the inner join, then BTC ETH and RJ, which is the right join. It's going to be true. It is not true. The time is not true, but it's supposed to be the same thing. It's supposed to be the same thing. Let me check my inner join again. What was our inner join again? This is that. It's telling me it is not the same with what I have here. So let me see. 261.7523 is supposed to be similar, but it's telling me it's not similar, but it's actually the same thing like inside. Let me see the code of it. It's actually the same thing. BTC ETH. We have this. So let me see for the right join. Maybe there's something that happened underground that you don't know. I'm supposed to have the same thing. So it's the same. It's the same. So I don't know why it's telling me that it is not the same. Okay, let me do something. Let me try a trick whether it's going to work. BTC underscore ETH. You know, if I do something like this, 2 equals 2. If I should 1 is going to give me a Boolean value, which is true. Maybe double operator. Maybe double. Okay, if it's true, I have to use assignment, like kind of assignment operator. So let me check BTC underscore ETH underscore ETH equals BTC underscore ETH right join. So only defined for equally sized data frame. And then equally sized, there's something fishy about this. Let me check the length of, sometimes you have to do some on that the background check of what you are doing. This is length 5. BTC. Like the number of column. Oh, sorry, this is supposed to be TH. Length 5. But I want to see the number of records. I can just use the date. The first column to search for that to see. The number of records is 1,645. Okay, what about for the right join? Maybe there's something you are missing here. Wow. So that's why we are having that issue. It is telling me that we have 1,647 entry here, while it is 1,645. So that is why we are having to be false. So there is something fishy here that we don't really understand. I don't really understand why I have different lengths for this result. So maybe we need to do a deep dive on, but then not in this class. So let's move on. I hope you get the logic I'm trying to work to drive at. So I want to see something. So you can use also the sorting function. Sorting function, we want to sort. So sorting now, let's talk about sorting. We still have a lot to cover. So in SQL, we have something like the order by clause. The order by clause is to sort in ascending order by default, but you have to specify that to sort in descending order. So we have the sort function here to do that for us. So let me see. Check the head. Let's compare the head of BTC underscore ETH, for example. Is that from 9th of August 2015? The closing price is 261. Now, let me say, okay, I'm not checking for this guy. I want to check for the closing price. So let ampersand closing price of X. So it starts from 261, 75, and all that. So by the time I convert this by the time I sort this, it might not necessarily start from this number because this number might not be the lowest. This number might not be the lowest. So let's see how that's going to work out. Let's say I want to see the edge. Or let me just type sort of BTC underscore TH. I want to sort the currency closing price. So this is what I have. So you start from the barest minimum from 203.18, 219, 2224, and all that. So is in ascending order from the lowest to the highest in that pattern. So that is how you can use the sort function. Okay, so we just use the sort function in data frame. You can use for vectors, matrices, and the likes of them. So you can also, by default, it is ascending. You can do it descending too. So you can do it descending order. So, but you have to put a parameter, say decreasing equals true. Then in this case, it's going to sort from the highest to the lowest. So in this case, from the highest to the lowest. All right. So there are so many other things to talk about, but I'll leave you guys to go and practice and see what they do. So we have what we call L apply. We have what we call S apply, and what we call I think we still have one other apply, kind of apply. I can't really remember. We have the normal apply too. So we have apply also. Remember apply. So how does this really work out? So this is how apply works out. So if you have a data in form of an array or matrix, and you can summarize this data, the apply function is actually really useful. It's actually really useful. So let's see how the apply function is going to work on. I will not do everything, so I will expect you guys to turn. So let's check for BTC. I'm missing a parameter. Oh, okay. Let's see. Should I use? No. Okay, let me see. I need the. I need the sum. I need the sum of the closing price. So let me say 2. So let me say 2 in this manner. What's happening? Sometimes this apply, this kind of apply, you have L apply, you have S apply. They don't really work for some kind of objects, maybe data frame. So let me see. It doesn't work for this. It doesn't work for this. It doesn't work for this. There's a way I can do this. Let me give us something. There's something I need to talk about. Let's say I want to talk about the summary before this. I want to talk about the summary of BTC. Now, this is what the summary gives us. For currency, since currency is a string kind of data type, so it cannot give us the 5-number summary and the mode and the mode or the mean, whatever. So summary for string kind of data type is going to give you the length of that column. Say currency, what's the length? 2,330. What's the class character? What's the mode? The mode is also BTC because it's just a univariate. It's just a univariate something. Date is also, you cannot calculate any kind of numerical operation on it. So, but look at closing price. It gives us the minimum. It gives us the maximum. The first quarter, that's like the 1/4 of your data. Like it's going to arrange the data in maybe ascending or descending order. And you're going to pick the one quarter. That's the first quarter. You have the median, which is like the second quarter. Your median is the second quarter. Then you have the third quarter. And you have the mid. But the 5-number summary is the mean, the first quarter, the median, the third quarter, and the maximum. So that's what we call the 5-number summary. So it gives for the numeric column of what we have in your data set. The apply function works for array or matrix. It works for array or matrix. So let's see how that actually works out. So let me try and create a matrix. So let's say math is equal to, I think we remember how to do a matrix. Let's say I need 1 to 20. 5,4 maybe by I don't really need that information. So this is the matrix I just created. So let's see, apply math. Let me see some. Let me see how this goes. The same argument 1 is missing. Argument 1 is missing very well. So this is what actually happens here. This is going to find the sum in row wise. So this is going to find the sum row wise. So what this actually does is that, okay, give me the sum row wise of this matrix. So sum of the first row is 34. Sum of the second row is 38. Sum of the third row is 42. Fourth, 46. So if I want you to do column wise, then the argument here I'm going to put here is 2. This gave me column-wise kind of sum. First column, second, third, and fourth. So you can do mean, you can do any kind of arithmetic operation, you can do that. So depending on what you want to achieve. I don't know. I think I can't do this. I can't do this with let me check again whether I can do it with the data frame. So let me check with that data frame etc. So let me say I need to I don't think I can do it with the data frame. So let me just check. 3 to maybe 5 or 6. Then comma. I will need this column wise. So let me see. I just want to apply the same logic. Okay, this actually works out. So this actually works out. So I found the sum of each column for the numeric character that is in the BTC, data set. So if I want to apply this and get the mean, what I just need to change here is put mean here. Let's go find the mean column wise. So L apply works with list. L apply works with list. So you guys, I will challenge you guys to do something around L apply and see that T apply is for tables. So do something around it. Because we'll be running up soon. So before I move to another thing entirely, can we please signify whether we are still getting along with this class? I've not heard from Suzanne. What's going on? Oh, Suzanne is no longer with us.
I'm listening to you.
Okay.
Yeah.
We might skip some things here because of time. So let's go to the next agenda we have here, which is session 5, data analysis using R. So we'll be talking about functions and packages in R. So let me just write this here. Data analysis. So I think this place we're going to talk about some useful things here. That's the module name. So let me just work with the session name. Using functions and packages. So functions and packages are very useful. Just like we have it in Python, we have libraries and all of that. So a function, so you have inbuilt functions like the sum, like the mean, T apply, S apply, so many of them, which are very useful. But sometimes you might want to create your own function to suit your own need. So you might want to create a function whereby, okay, this function is going to go into a data set and find the monthly average of maybe a customer table or a sales table. Let me say sales table. So a sales table, you have daily sales there. Then you just write a function that, okay, whenever I just put this function, I write this function, I put in the sales I have, So this should give me a monthly average, a monthly moving average for the particular sales for a particular period. So let's say you have data for 365 days. So it means that the function should subset data maybe in 30 days. So calculate the sum of the first 30 data divided by 30, go to the next 30 divided by 30. So it might not necessarily have these functions in R, but there is a way you can combine one or two things and turn it into a function that can be useful for you. So it is because of for you to be able to reuse. So you have performed some kind of analysis, you have done some kind of manipulations, but instead of it to come back, maybe you have the same kind of thing, same kind of procedure you want to take on a particular data set again. You just have to go about it all over again. But since you have done it, you can just compile everything into a function. Then if you have similar thing you want to do that will take you through that same process, so you don't need to go through it again. You just have to call that function you have created, then put in the data set there, then it's going to do everything for you instead of having to do everything again. So that's the essence of function. And packages, you have packages where they have this different kinds of capabilities to do some beautiful things. So let's delve into the stuff we have for today. So first, the first thing here is creating a script. Creating a script. This is a script. This is a script. This is a script. So, but there's a way I'm going to do it whereby maybe I have something that I've saved here. I might want to turn a particular process into a script. So what do I mean by that? So that by the time I just run that, it's just to run the code from top to bottom and return the output. So let's see an example of that. So let's see. I'm going to open a new script, a new code editor entirely. So that file our script. Okay, I have this. So there's this process without wasting much of our time. So just to get the idea of what we're talking about. So I have this guy. Let me see. 1 to 10. 1 to 10. Percent is round is a function in R that rounds your floating value to a particular decimal place. So x times 100. No? So I want to do. I'm not doing x times 100. I want to do x divided by sum of x. Then so let me put this in brackets and put another bracket here. Then times 100 digits is equal to 1. I will explain this kind of code. Then I think this captures this part. Digits is equal to 1. Then I will say result is paste percent comma this comma separated by empty space. Then print result. So I'll let me comment at this top. I will say building a script. In R. So now I will explain. this X generates a sequence of 1 to 10. Now, this one is saying that, okay, assign this guy to percent. So what is this guy doing? So let's go from the inner operation to outside. So what is happening inside? Now, inside round, you have X over sum of X. So what is this guy is doing there? Take each X divided by the sum of X. So it's going to create a kind of decimal. So this is like a cumulative percentage, a kind of cumulative percentage somehow. So X divided by sum of X. So you're going to have 1 over sum of X, 2 over sum of X, 3 over sum of X, to 10 over sum of X. Now multiply each result by 100, then round it to 1 decimal place. That is by the way. So the result, so it has assigned this operation to an object called percent. So this percent is having each of these sequence it's converted to like a kind of percentage. Now this one is saying that, okay, paste result is now going to be like paste percent, comma, paste is like a kind of concatenating function too, but it's like a kind of print. Let me say concatenate, a print function. So it's a kind of print function. So paste percent, comma, then I put this guy in quotes. It's kind of a string formatting. So I want the percent, the number. You know, this guy is a number, this percent is a number. Let's say 20. So place this with this, separated by what? Separated by a quotation mark that does not have space. So I want the percent and the symbol percent should be together. So after 20, there should be percent. So you should put it in this format, in this form. You should have something like this. So this is how I want it to display the result. I want it to display it in this manner. So then after you have done that, you have assigned each of the percent in this manner, put it as result, then print it. Now if I want to run all this query now at a time from top down, I'll press Ctrl Shift Enter. Oh sorry, Ctrl Shift Enter. So this is the results: 1.8%, 3.6%, in 1 decimal place, 5.5%, up to this. So if you find the sum of results, it's going to give you 1. It should give you 1. The sum of results should give you. Oh, results. I cannot sum results. Sum of percent, because percent. I've done the string formatting on results. So it's give you 100%. That is 100. So I cannot sum result because it's not. So how do I convert this? Into a script? So how do I convert this into a script? First of all, I will save this now. I will save this guy. It's Ctrl S to save. I want to save it, Ctrl S. Ctrl S to save. I hope I have the permission to save here. So let me call the script paste percent. If this thing should give me an error. Paste percent. It's supposed to be a .alpha. Save. Okay. I think that's saved. It saved the document. Save the document. Let me get my working directions to be sure that I deserve to have it in documents. Get working direction. It's in document. Okay, now the next time it should be a .alpha. So if you want to call a script, so if I want to call this process again, the next time I come to R, one thing I just need to do is I'll say source. Then what's the name of the script? Paste percent dot R. Then if I should run this code, it should give me this, the final result at the end. So as you can see, it will just run everything and give you the output. Does this make sense to us? Hello, hello. I feel like I'm the only one here talking.
For me, I have to go through it for me to understand it. I'm following you.
Okay. So this process I just did of printing this result in kind of function, in kind of percentage format, I can convert it to a function. This is how I'm going to do about that. I don't want to waste much time on this anyways. I'm going to do something like this. I'll say, instead of paste percent, I say paste percent is a function of x. There's a way you write function in R. It doesn't really suit me when I'm doing it in Python. It doesn't really suit me, but just have to adapt. Now, this function takes an argument called x. Now, this x has to be a vector. Though you can find a way, you can find a way around it to do it to make this function work in a data frame. Though I've tried something like that before, but I don't think I can just try and do something and back over my early values. Let me see. I don't know whether I have it here. I've done something like this before, but I don't have it here. So this function is going to take a parameter x. Okay, what is it going to do? What is it going to do exactly? So enter. This is just a kind of formal way of writing a function so that all your code is going to align there, to follow kind of alignment. So percent is, I'll just copy this guy. I want it to perform this operation. Okay. Then result, I want it in this format. Okay. Then instead of me to say print result, I'll just say return result. So return is just a function. Return result. There. This is all. So I can, if I should, I'll just highlight. If I want to turn this into a script. So percentage, paste percent is the function. So it's a function of x. Okay. What is the function doing? It's doing all this. I'm going to return this. So if I want to execute and turn this to a function, I highlight everything like this. Control enter. So it has run successfully. So paste percent now is now a function. So you can use it with any vector. It's not necessarily this x. You know, when we did that in script, this x is a constant. So we can use it with any kind of x per se. So I can say, I can reuse this function and say paste percent. Say, let me say 1 to 20. I can say, I can get a vector 1 to 20. It's going to perform this operation on it now. No. This is not it. This return is supposed to be at this place. It's supposed to be here, not underneath them. I think that's what is causing that error. So let's do it again. Paste percent. So the way you write your code sometimes, you have to be very careful. Okay, it still doesn't work. Let me assign an x. Let me assign an x to 1 to 20. So x is now 1 to 20 this way. So let me put x here. So if it doesn't work here again, then there's something wrong. Okay, now there's something wrong. Let's try and debug our code. Result is paste percent separated by this. Oh, sorry. I said return x. I didn't say return result. It was supposed to be return result instead of return x. So it's supposed to return result. That's why it was returning x instead of result. So sorry about that. So let us execute the function again. Okay. Then we should be able to use the function proper now. So I don't even need to do this. I can just put the vector here. 1 to 20. So you can see. So you can perform this on any vector per se. Let me see whether we have the PTC. The PTC. I want to test this on PTC data. I have a reason. I want to test this on PTC data. So edge PTC. Okay, I still have PTC. So let's say I want to test the paste percent on the closing price. The closing price of BTC. So BTC ampersand closing price. So you can see it. So you can only work on vectors. So everything is having 0%, 0%, 0%. Why? Because the precision I gave is 1. So and there's no way this thing is not going to be 0% because if I should sum the price, the sum of the price will be so large whereby if you approximate it to 1 digit, you are going to have 0% for everything, obviously. So if I should increase the precision, so let me say 10 decimal places, and we want this again. So I increase the precision of the function. So let me put it on this closing price again. You can see now. You can see you have 0.0558 blah blah blah. So it's because of the precision, because it's almost close to 0. So I think the 10 precision is too much. Let me just put 3. Okay, then do it again. So we have 3 decimal places. You can have 0.006, 0.005. So everything does not necessarily have to be 0 now. So that is by the way. You have less than 15 minutes to end of this class. So that is how you can turn your code to a function if you want to reuse it again. All right. Now, I might want to create a function. The limitation of this thing is that what if I have a list? So I want to check something. Okay, I don't want to go into details, so I won't waste more time. I don't want to go into the design first. So let me see what we can also look at. So there's this function there's this method you can use. There's this method you can use. We call it is. It's very important. It's very important. It's very important. I can say, okay, I can say, go into something, go into a list, or go into a list, and check for a particular element. Check whether the element is numeric or not. Something like that. Something like that. So I can say, look at, let me give you a basic example of this. So is dot numeric. So this is going to check whether 2 is a number or not. So if it's a number, it's going to return true. Yeah, it's numeric. So if it is not, let's say hello. Hello is not numeric, it's going to return false. So things like that. So look at BTC, for example. So if I say that is dot vector, I want to say, BTC is not a vector, it's a data frame. So if I say is dot vector BTC, it's going to return false because it's not a vector. I can also say is dot data frame. So I want to check on, okay, it's not a vector, I'll check that it's not a vector. Okay, check whether it's a data frame. So it does data dot frame. So it's done true to check whether to verify that it's a data frame. So this method, you can actually use them, it's very important. So you might want to create a function that will look through the elements in a vector per se, or a list per se. So okay, check into this list, check the data type. So I want to check whether all the elements are of the same character. Okay, check into this list, check for each element, are they a character? If it's a character, it's going to return true. So if there's a one that is not a character, maybe it's a number, it's going to return false. So things like that. Now, when I was creating this function, I was using braces. As you can see here, I was using braces. There's another way I can do this without using a brace. Okay. Dropping. Let me say dropping the braces. Let me call it dropping the braces in the function. So, suppose I want to create a function that's going to print all the numbers in a particular vector. So let me create something like that. Print. I'll call it print element. I'll call the function print element. And I say is less or equals to function is a function of one variable, say x. Literally when I was creating the function, I put braces. Instead of me to put braces, I'll just put space. And I'll move on. I'll now say if I in range, so if I in one length of x, if I in length return I. So return x of I. So what is this guy going to do for me? So there's a I have an, okay, sorry, I'm supposed to put this in brackets. If I in, so this is I'm still having an error. There's something I'm missing here. There's something I'm missing. Sorry. I think this should work, not if. So for I in one semicolon length of x. What am I saying in essence? So this is going to go into x. Okay, for any element you find in x, return that element. So that's what this one is saying. It's a for loop. So I'm going to talk about for loop later as we move on in this class. So this one is saying go inside x. For every element you find in x, return that element. So for I in so obviously sorry, this is not the way I'm supposed to type. This is not the way I'm supposed to type it, is it? Okay, I think this is how I'm supposed to type it. So for I in x, for every element in x, return I. So okay, go. If you see banana in x, return banana. Then go again. If you see apple, return apple. In that manner. So I've avoided writing braces and all of that. So this is just a simple function. So let me execute this function in this way. I don't even need to highlight it, it's on the same line. So, okay, it gave me an error. Oh, sorry. I'm supposed to put this in this. I'm supposed to put it in this, I guess. So I have this. So let's see what is going to happen. Let's try it with. Let's try it. We created an x one time like that. Let's check what x is. So x is 1 to 20. So if I do print element x, so it should return 1 to 20 for me. Oh, it just returned 1. What happened? Okay. So let me tweak the this thing again. Let me tweak it again. Okay. So let me tweak it this one again. Okay. It's not giving me my desired results. That's why that is baffling me right now. So there's a reason I'm supposed to tweak it. So the point is that I can avoid writing braces. That's the point we are trying to achieve here. So we are going to talk about the for loop, while loop, and the likes of them. So as we proceed in the class, it's not going to be in this class anyways. So the point is that I can avoid the braces. Instead, in this case, I have braces in the function to specify that okay, I want this way I want to write my codes and all the likes of them. So instead of using braces, I can just use space to align my code. So that's the point here. Okay. Now, the last thing for the day. You can also use functions as arguments. You can use function as argument in when you're writing your command. You can use function as argument. The function can be your argument. So what do I mean by that? So what do I mean by that? If so, I might want to. Okay, I might want to. I can put a function inside a function. So that's what I mean by that. A function can be inside a function. There's no crime. There's no crime. So, for example, I can say, look at this now. I got to load the function that time. Paste. Let me just copy this. Paste. I said paste this, which actually pasted this. So I can write a function that, okay, I can put a function that, I can put this guy into a function again. I can say print elements. You know, I've already said print, I've defined the function print elements. I can say print elements, paste this. So it return the first value, which is what my print element is doing. So I can put a function inside the function. So a function can be an input, can be an argument. So that is by the way also. So one last thing before we end this class is using the dot argument. What do I mean by using the dot argument? Using the dot. So in some functions, let me use some for example. Look at this. You can see what I have here. You can see dot. It means that your sum function is not limited to a single argument. Compared to this function x now. Function x only takes one argument, and this print element only takes one argument. So if I want my argument to take in as many value as possible, then the dot is going to come in. The dot is going to come in. So it says that you can put as many parameters as possible, depending on the function you just created. So let's see one example. So we have, let me create a function called add%. So add% is going to be a function of x. So say multi 100. So dot. Then I put a brace. I'm using brace here. Percent is equals to round x times multi comma dot. So this dot is optional. When you put a dot in function, it means it's optional. So you might not necessarily add another parameter. You might want to add another parameter. So it's optional. It's always optional. So paste percent, like something similar that we did the other time. Then separated by just this. So as you build this function, it is going to work fine as the first one we did. But as you can see here, if I don't put anything in this space, if I just put in the first two parameters, it's going to work fine. But in this case, in this scenario, multi is constant. Now, if I should come here and execute this guy and execute it, Now, if I want to call this function, I necessarily do not need to put a value for multi. I necessarily do not need to put a value for this multi guy. So let me use the function add %. What I just need is to put the x value, which is like a fractional value. Let's say 0.23, 0.114, 0.5. If I should run this, okay, it said couldn't find function add %. Okay, I didn't write it very well. I said app instead of add. So if I should run this, you can see it gave me a result. I necessarily do not need to put the multi % because it has been defined. Whether you put it or not, it has been defined. So if I should put multi equal to 100, I can say comma 100. I still have the same result. Okay, let's try and put 50. Let's try and put 1000. You can see the result has changed. But if you don't put it, it's going to take in the default value that you use when creating the function, which is 100. If you don't specify, but if you specify, it's going to use what you just specified. Let me try and put something there. Let me try and put 56 here. Now this 56, you can see it accommodates another parameter, but it is not using the parameter. Now, because the parameter is not specified to be used in this percentage, in this place that we specify the operation for the add %. The parameter is not used. So if you just put it there, it's just like a dummy variable. It won't be used. If I put as many as possible, 23, 25, I can put as many as possible. You say 4 arguments pass through. I can say 4 arguments pass through round. Oh, sorry. Forgive me. Now in this case, if you notice something, let me put something here. 0. Let me put another 0 here. 0, 0, 0. So let me put 3 here. I will explain what this one is going to do for you. Now, since your ... is in the round %, is in the round function, your ... is in the round function, and round can take 3 arguments. So what it's going to do is that it's going to take this next argument as your multi, then it's going to take this last argument here as the number of precision you want to have for your result. So it's converted this to 3 digits. So if I put 4 here, it's going to convert to 4 decimal places. It's converted to 4 decimal places, as the case may be. So, but if I should repeat this add % here, okay, let's say I want to tweak this guy a little bit here. Now, if I should remove this ... from this round that I just put here, and I leave it as it is here, let me now run it. Yeah, so if I should put as many as possible values here, you shouldn't consider this value. Even I should put 1 million, this value shouldn't be considered. So the only thing it's going to consider is this first and second value. That's how it's supposed to work. So you can see 0%. So all this extra 5 values that are added is not considered because it is not used forever in this case. So it's optional. If you put it based on what you have defined there, it won't be used. It will just be there as a dummy variable. So I think that's going to be the end of today's class. I will implore us to go through our essential book 1 and go through the lab manual, so and study ahead, and so that we can move at a very fast pace. If you have any questions as to what we have done so far, so we can attend to them also in the next class and see how it goes. Hello, am I still in this class?
Yes, yes.
Yes, Emmanuel.
Okay. All right. Okay, this is the end of today's class. So Susan, is Susan still available? All right. Thank you, guys. Thank you, guys.
Thank you, Emmanuel. Well done. Then.
Thank you,
Yeah,
man.
thank you very much.
All right. All right. No problem. You guys should have a great weekend.
All right, you too.
Susan, how was the class today?